Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over problems 34 to 37 of the June 2015 Algebra 1 Common Core Regents exam. All right, let's take a look at problem 34. It reads, the equation to determine the weekly earnings of an employee at the hamburger shack is given by W of X, where X is a number of hours worked. So we have the piecewise defined function here. The first question, determine the difference in salary in dollars for an employee who works 52 hours versus one who works 38 hours. Okay, so we want to find a difference here. Now I'm going to set up this piecewise defined function in a visual way so that you can really understand what's going on here. So let's draw a number line. So this number line is going from 0 all the way to infinity. So we have 0, and let's say that's 10, 20, 30, 40. Okay, and then it just goes on and on. Now, what does this piecewise defined function tell us? Well, it tells us that if the hours worked is between 0 and 40, 0 and 40 included, this is a function that's active. Okay, so how can we illustrate that on this number line? Well, all we just have to do is we're going to draw a line from 0 to 40. Now, from 0 to 40, 0 and 40 included, we have full circles here. The function, let's put it in green, the function W of X is going to have the value 10x. So that's the function that's active from 0 all the way to 40. All right, so how about the second interval, x greater than 40? Well, let's go ahead and draw a number line for that. So from 40 to infinity, 40 excluded, so we have an open circle here. What function is active? We have this function active on this interval right here, x is greater than 40. So on this interval, we have W of x equals 15 times x minus 40 plus 400. Okay, so this number line is basically x hours. All right, so there goes a visual way of looking at this piecewise defined function. Okay, all right, so in this problem we're asked to find the difference between working 52 hours and 38 hours. So what are we doing in essence here? In essence, what we're doing is we to find W52 minus W38. What do you get when you plug 52 into this function? And then what do you get when you plug in 38 into this function? And then when you subtract it, that will be your answer. Okay? All right, so we're going to do this step by step so you understand what's going on. Let's start with W52. All right, so for W52, x is equal to what? X is equal to 52. That's your input. Now, when x is equal to 52, so let's write it down. For x equals 52, what is the function that we're going to be looking at? For x is equal to 52, let's look at the intervals right here. Where is 52? 52 is clearly higher than 40, right? So 50, if this is 50 right here, 52 is somewhere here. So anything greater than 40, we're going to be using this function down here. So we're going to be using the blue function, W of x equals 15 times x minus 40 plus 400. All right, so let's go ahead and evaluate it. What is W of 52? We simply plug in 52 into the second function. All right, so it's going to be 15 times 52 minus 40 plus 400. All right, you can calculate that with your calculator. It will give you 580. Okay, so that's how much you earn if you work 52 hours. Now, what about if we worked 38 hours? What would the earnings be? So for x equals 38, what function are we using? Where is 38? 38 is in this first interval right here. Okay, so that means we're going to be using the function w of x equals 10x. Okay, so let's go ahead and evaluate w of 38. What is w of 38? Is what you get when you plug in 38 into this function, the first function. Okay, so you have 10 times 38. That's clearly 380. All right, so now remember the task was to find W52 minus W38. So let's go ahead and look for that. So since W52, let's write that down. Since W52 is equal to 580 and W38 is equal to 380, the difference W52 minus W38 is just, you just subtract these two, right? It's 500 minus, actually not 500, 580. It's 580 minus 380. Okay, so 580 minus 380, and your answer is 200. Okay, all right, let's move on to the second part. All right, so the second part reads, determine the number of hours an employee must work in order to earn $445. Explain how you arrive at this answer. So you're not just solving an algebraic equation here, you're solving and explaining your thought process. How did you arrive at the answer? Okay, so basically what this problem is asking us to do is to solve w of x equals 445. That's what we're trying to do. We're trying to solve this equation. But we have some ambiguity here. Why? We have two functions. What is w of x? Is it the top function? Well, let's do this. Let's label it, okay? We're going to call this 1, and we'll call this 2, okay? Well, I think if I change the color, that would be better. So this is 1 here, function 1, and then the second one is 2, function 2. We have 2 w of x. Which one are we going to plug into this setup to solve for x? Which one are we going to use? That's the question. Well, in order to determine which one to use, we can take a look at the first interval and ask ourselves, what is the highest earning that this function can generate? Okay, so let's go ahead and write that down. We're going to call it maximum for function 1. So maximum earnings for function 1 is what? How do we know the highest amount of money you can earn from this function? You plug in the highest value in this domain, okay? And the highest value is 40. So if I plug in 40 into w of x, I will know what the highest, the maximum earning it can be, okay? So w of 40 is going to be 10 times 40, which is 400. Okay, so function 1, let's just put a side note here, is w of x equals 10x. So why are we doing this? Why are we looking for the highest amount in the first function? Well, we want to know if 45 is in that interval. Okay, so we got 400. What does that tell us? It tells us that 445 is too big for the first interval. So if it's too big for the first interval, we have to use the second interval. Okay, so 445 must be in the second interval. All right, so 445 must be for function 2 or the second interval. Okay, all right, so we are now good to go. We now know what function we're going to use. We know that there are two functions. We're using the second function. All right, so what is function 2? Function 2, w of x is equal to 15 times x minus 40 plus 400, okay? That's where 445 can be. Now we're going to set this equal to 445, so we're solving the equation 15 times x minus 40 plus 400 equals 445. Okay, we want to solve this equation for x. This tells us the number of hours that an employee must work in order to earn $445, all right? So this is an algebraic equation. We can do this in 3 steps. Get rid of 400, 15, and then negative 40. All right, let's go ahead and do that. Subtract 400 from both sides. That yields 15 times x minus 40 equals positive 45. Let's get rid of the 15, divide both sides by 15. Okay, that gives us, what does that give us? X minus 40 equals 45 over 15 is 3. And then lastly, just add 40 to both sides. And then you have x equals 43. And the unit here is hours. Okay? All right, so are we done with this problem? Absolutely not. We are asked to explain how we got our answer. If you want to get full credit, you have to explain here, okay? So let's explain the procedure we used to arrive at our answer. So to find, let's correct that, to find the number of hours an employee must work to earn $445. We set w of x to 445. Okay? The first function on the first interval has a maximum earning. What is the maximum earning for the first interval? We already calculated it. It was 400. It has a maximum earning of 400, which is too small. Okay? Which is too small. So we used the second function to solve for x. Okay? Solve for x, which is equal to 43 hours. And that's basically the whole idea right there. All right, let's take a look at problem 35. It reads, an online electronics store must sell at least $2,500 worth of printers and computers per day. Each printer costs $50 and each computer costs $500. The store can ship a maximum of 15 items per day. On the set of axes below, graph a system of inequalities that model these constraints. All right, so before we start, you just want to recall a formula. We went over this earlier in other parts of this installment. We talked about the cost formula, all right? We said that a total cost is unit price times what? Unit price times quantity. Okay, so that's going to come into play here. Now, let's go ahead and declare our variables first. So let's see computers right here. You see the computers. What axis is it placed on? It's based on the y-axis, right? and then printers x-axis. So let's follow that pattern. So let x equals the number of printers, and let y be the number of computers. Okay, so we have our variables declared. Now let's go ahead and set up our system of inequalities. Now the first one, let's do the easier one, the total number or quantity inequality. You can ship a maximum of 15. So what does maximum mean? 15 or less. Okay, so this is equal to, this is less. What happens when you combine equal to and less? You get less than or equal to. So that's going to be our inequality. Okay, so let's deal with the total quantity inequality. Quantity inequality. All right, so quantity inequality, what is the total quantity of printers? X. Quantity of computers, Y. So if you add both of them together, it has to be less than or equal to 15 or a maximum of 15. Okay, so that's the first inequality we're going to be dealing with. Next one is, well, let me just put this in, well, probably we can do that later. The next one is the total cost inequality. Okay, so let's write it down. Total cost inequality. All right, what's the total cost inequality? Well, the cost for printers is going to be the unit price of printers times the quantity of printers. Okay, what is the unit price of each printer? Each printer costs $50. How many printers did we buy, or how many printers were shipped out? X printers. Okay, so we combine them together, we'll have 50x for the total cost of printers. Do you see what the total cost of computers is going to be? The unit price is 500 and the total is Y. Okay, so you just multiply. Remember the formula, unit price times quantity tells you the total cost. So the total cost for computers is 500x. Okay, 500y, sorry about that. 500y, because y is the number of computers. So what is the inequality we're looking at here? It says at least. What does least mean? At least 2500. Least means it cannot go below. Okay, it's like a floor. At least means greater than or equal to. That's what least means. So 50x plus 500y has to be greater than or equal to at least 2500. So those are the two system of linear inequalities we are going to be graphing to show our feasible regions, and then we'll shade the solution. All right, so let's go ahead and graph them. So I'm going to label them 1 and 2. So this is 1 and this is 2. We went over this in other installments of this review series. We talked about the best strategy for graphing linear inequalities. And we said you want to get the variable y by itself. Place it in slope-intercept form. Okay, so that is exactly what we're going to do. We're going to place them in slope-intercept form and then graph them accordingly. All right, so let's start with the first one. So from the first one, we have x plus y is less than or equal to 15. This is easy to get y by itself. You simply subtract x from both sides. And then you get y is less than or equal to negative x plus 15. Okay, negative x plus 15. All right, so in order to graph this, we need the slope, the y-intercept, and the shading pattern. Okay, so for this one, there is a 1 here, so m, the slope, is going to be -1/1. Where do we start from? You start from 15. Since we have less than or equal to, that means that it's going to be solid, and we're going to shade where? Shade down. Less than means solid shade down. Okay, greater than means, or equal to means solid shade up. So these are the pieces of information we're going to use to graph our line. All right, so we start from the y-intercept, 15. So let's go ahead and do that. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, 10. So 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's our y-intercept. Okay, so let's go ahead and graph our y-intercept. All right, so our slope is -1/1. How do we graph that? This is 15. How do we graph -1/1? Negative rise means you fall and you run 1. You fall 1 and run 1. That's the slope, okay? So from this y-intercept, you fall 1, run 1, fall 1, run 1. That pattern continues forever, okay? So we have a solid line, and we're going to be shading down. So let's go ahead and draw a solid line through those points, like that. Can go below there, since you can have negative number of computers. So right there. Okay, and then we're going to be shading down. I'm not going to shade it yet, so I don't make a mess. I'll just show you the direction of the shade. So since it's less than, we're going to be shading down. Whenever you have a system of linear inequalities, you don't want to shade until you know where your solution region is. All right, so we're going to shade down. Okay, let's take a look at graph number 2. Graph number 2 is 50x plus 500y is greater than 2500. Now this one, we need to do some work here. What are we going to do to make it easy for us to graph? We want to get y by itself. Okay, let me divvy up my workspace so we don't get confused. Okay, so we're going to get y by itself. To do that, we can do that in 2 steps. Move 50x to the right and divide by 500. Okay, so subtract 50x from both sides of your equation. That gives you 500y is greater than or equal to -50 x plus 2500. And next thing we're going to do is divide both sides by 500. Okay, so divide both sides by 500, divide by 500. Remember, the goal is to get y by itself. 500, 500. So what do we get when we reduce that? If we reduce that, we'll have y is greater than or equal to, zeros cancel out, 5 goes here once, 5 goes here 10 times, -1/10 plus 2500 over 5 over 500, the zeros divide out, 5 goes into 25 5 times. Let's not forget our x. Okay, so that's the point slope form. Not point slope, slope intercept form. So now that we have the slope intercept form, we are going to look for our slope and y-intercept. Okay, so slope is a coefficient of x, of course. M is -1/10. And our y-intercept, where we're going to be starting from, b, is +5. Okay, so you rise -1, you drop down 1, and you run 10, starting from 5. What does this inequality tell us? Greater than or equal to. That tells us it's going to be a solid line, and then you're going to shade where? You're going to shade up. Okay? All right, so let's go ahead and do it. We start from 5. You mark 5 right here. And then you go down 1. and run 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 right there. Okay, so that's sufficient. We just go ahead and draw our solid line like that. Okay, so it goes on in that pattern forever. Now, where are we shading here? Since it's greater, we're going to shade up. So our shading is upwards, going up like this and going up like that. Let's label our graphs. So this one, the first one we did, this is x plus y is less than or equal to 15. And then this second one that we just graphed is 50x plus 500y is greater than or equal to 2500. Where is our solution? Let's say this is 1, 2, 3, 4. Let me put the numbers there. This is 1, 2, 3, 4. Let's say we have these 4 quadrants. Where is our solution going to be? Well, you can pick the solution. You can pick the interval where the 2 arrows are pointing to. You cannot go behind any arrow. Okay. So if you look at region 4, no arrows pointing there, so it can be here. Region 1, only 1 arrow is pointing here. This one is not pointing there. You cannot be here. Region 3, only this arrow is pointing here. This one is pointing somewhere else, so that's a negative. Region 2, notice both arrows are pointing here. So this is our solution region to the system of linear inequalities. Okay, so let's go ahead and shade it. So you don't have to make a mess, just make nice concentric lines. That's sufficient. And that right there is your solution. Well, what does that mean? It means that any coordinate pair in this interval is sufficient. Will satisfy the system. It could be on the line, on the boundaries, or on the interior. Okay? All right, so let's move on to the next question. It asks, determine a combination of printers and computers that would allow the electronic store to meet all of the constraints. So here, what's the answer here? How many answers are there? If you look here, any point in this interval, in this shaded region, will suffice. So we have an infinite number of combinations. So all we just have to do is simply pick any point in this shaded region, and that will satisfy the constraints. So what I'm going to do, let's call this 2 and 6. Is that a solution? Absolutely. Why? Because it's in the shaded region. All right, so let's go ahead and write down our answer. We're also asked to explain how we obtain our answer. A combination that meets wrong spelling. A combination that meets all the constraints is 2, 6. What on earth is 2, 6? In the context of printers and computers, what does 2, 6 mean? 2, 6 basically means 2 printers and 6 computers. Okay? So let's write that down. 2 printers and 6 computers. Now, how do we know that this is the answer? We obtained our answer. Let's write this down. We obtained our answer by selecting a point in the solution region. Okay, in the solution region shaded above. Okay, so that's why, or basically that's how we got our answer. All right, let's take a look at problem number 36. Sorry, it says an application developer released a new app to be downloaded. The table below gives a number of downloads for the first 4 weeks after the launch of the app. Write an exponential equation that models these data. Use this model to predict how many downloads the developer will expect in the 26th week if the trend continues. Round your answer to the nearest download. Okay, so let's answer the first one. Generating an exponential equation that models that pattern, this growth rate. So all we just have to do is use exponential regression in our calculator, and this should be a piece of cake. So what we're going to do, we're going to go to statistics, and we're going to edit and enter the number of weeks and number of downloads in the first two columns of the stat entry list. Okay, so in list 1, let's enter the number of weeks. 1, enter, 2, 3, 4. Okay, so that's that for list 1. The second list will be the number of downloads. L2, 120, 180, 270, and 405. Okay, so you just enter the data into your calculator. Now what we're going to do is use our calculate menu in the statistics option to generate our exponential regression model. Okay, so this is already entered. Press stat again. We're now going to go over to the calculate menu. So scroll to the right, and then you have a whole bunch of calculate functions here. For the statistic menu, you just scroll down and you're looking for exponential regression, EXPREG. Press enter, and what do? We just enter the two list 1 and list 2 that we entered earlier. So second function 1, you see the yellow here, that's list 1. Second function 1, list 1, comma, second function 2 for list 2. Enter. There goes your exponential regression model. Okay, so what this calculator is telling us is that if you're following this format, y equals a times b to the x, a is 80 and b is 1.5. So what do? Just plug in these two values into this formula, and then we get our answer. Okay, so we have y equals 80 times 1.5 to the x power. So that's that. Okay, now the second part says how much would you expect in the 26th week. So to do that, all we're just looking for is we're evaluating y of 26. What is y of 26? How do you do this? You simply plug in 26 into the x there. So you have 80 times 1.5 raised to the 26th power. Okay, so let's have our calculator do the heavy lifting here. So we're going to do 80 times 1.5 raised to the 26th power. Enter. Let's see. 3,030,140. So in this problem, we're rounding to the nearest download. Okay, so we're rounding to the nearest download. So it's simply going to be 3,030,140 downloads when we round it to the nearest. When we round it to the nearest download, we just truncate this decimal piece since it's less than 5. Okay. Now, next part says, will it be reasonable to use this model to predict the number of downloads past 1 year? The answer is no. No. Why not? Because the farther you are away, the less accurate your prediction will be. Okay, so that's basically the reason why you don't want to use it for greater than 1 year. So for this problem, you cannot just say no. You have to explain what's the thought process. Well, how do you know? Why do you come up with no? Okay, so no. Why is it no? Because the farther you are away from the data set, the less accurate your model becomes, okay? Right? So our data sets tops out at 4 weeks, and a year is 52 weeks. So 52 weeks or greater is very far away from 4, which will lead to a very inaccurate prediction, okay? It's going to be really flawed, a very inaccurate prediction. So it's just accuracy problems that we're having here. So since going too far away from 4 results in an inaccurate prediction, it will be unreasonable for us to use the model for 52 weeks because it's way too far away, introducing too much room for error.